Hi everyone. So this is your first video notes that we are taking this year. You're going to do this for the rest of this unit for the most part. So you will be taking all your notes at home from now on. And remember that I'll still be doing those notebook checks just like I did last week. Okay, so today's title, you can write this at the top of your notebook page, is PS 1.1, Atoms, Molecules, and States of Matter. And then remember to include today's date. That'll just help you to organize it. If at any point this video is moving too fast, you can of course pause it, and that's one of the advantages of doing the notes at home, is that you can move at your own pace instead of having to rush if you're somebody who writes a little bit slower. Okay, before we jump into today's topic, I wanted to talk a little bit about why we take notes. We've talked about this a little bit as we've done it over the last couple weeks, but I want to dig in a little bit more. So why do we take notes? We take notes because research shows that writing things down actually helps us remember things. So we've talked about synapses and neurons over the last couple of weeks, so you all know how that works. As you write things down, you are creating new synapses in your brain. So every time that you're writing down a piece of information, you're helping your brain to travel that pathway a little bit faster, and you're going to remember that stuff better. As usual, as we've been doing over the past couple of weeks, please keep writing this into your notebook by hand. That actually is different than typing. It's better for your memory. It's better for your neurons. So keep doing that by hand. And I will be doing notebook checks as we go through. Okay, so what should we write down? It's the same stuff we've been doing over the last couple of weeks. You should write down all the vocab words, any interesting facts, and any data or statistics. This is an opportunity for you to get better at note-taking. In class, I was telling you exactly what to write down every time. There are some things that you definitely need to include, but then there's also some stuff that you can go above and beyond and include that in your notes as well, because that's the kind of stuff that will help you remember things better. Okay, so remember, just like always, we have this pencil up here, so this is definitely something that you need to have written down into your notes. It doesn't mean you need to include this chart, but include this vocab word in the definition. So our first vocab word is atoms, the basic unit of all matter. They are smaller than you can imagine, and they make up everything. So everything that has any mass at all is made up of atoms. I'm going to move on. Feel free to pause if you need to. All right, do a quick estimation. You can write this down in your notebook. How many atoms do you think are in your body? Maybe you're thinking like 200, maybe 1,000,000. Go ahead and write down your estimate. Okay, so write down, once you have your estimate written down, multiply it by 200 billion, because this number is probably bigger than you can imagine. So in a single cell in your body, there are about 100 trillion atoms in a single cell. And you know just from our brain science unit that you have many, many billions of brain cells, and that's just your brain cells. So you have a ton of other cells in your body. Each one of those has 100 trillion atoms. So atoms are exceptionally tiny. Okay, one cell, 100 trillion atoms, 100 trillion atoms. And this is another way of saying this is that one of your cells has as many atoms as an average beach has grains of sand. So in just one of your body's cells, you have as many atoms as maybe Revere Beach has grains of sand. All right, next vocabulary, make sure you're writing this down. Molecules, groups of connected atoms. There are lots of different combinations. So atoms are joined into these things called molecules. You can see images down here in the corner of some different molecules. So this is an oxygen molecule that's made up of 2 oxygen atoms. This is a water molecule, which is made up of 2 hydrogen atoms, those blue ones, and then 1 oxygen atom. So basically, molecules are just combinations of atoms. Sometimes they're different atoms, sometimes they are the same atoms. And I just put some images of some things that include molecules. Again, everything that you can touch is definitely made out of molecules. Air also has molecules in it. you can actually touch air, and it does have mass, so it's made up of atoms and molecules. Okay, next up we have states of matter. You guys have probably learned about this in earlier years. So we have gas, liquid, and solid. There's also plasma. We're not going to get into plasma as much this year, so I really want you to focus on gas, liquid, and solid as the states of matter. Substances change state of matter when they lose or gain thermal energy. So remember from earlier today, thermal energy just means heat energy. So when a solid here in this image, when that gets more thermal energy, as in when it gets hotter, it's going to heat up and then it eventually turns into a liquid. You see this anytime you melt ice. If that liquid continues to get hotter, maybe you put that liquid on the stove in a pot, then eventually it's going to turn to gas. So when you see steam rising up, that is because this liquid has gained enough thermal energy that it's turning into a gas. The opposite is true. If you then cool down that gas, it's going to turn into a liquid. And if you cool down that liquid, maybe by putting it in the freezer, it's going to eventually turn into a solid. It might be helpful to add this diagram to your notes. All right, and then some quick facts about the states of matter. This might feel familiar. Just jot down these quick notes. Solid is the lowest temperature. These molecules have very little kinetic energy, though they do still have some kinetic energy. And they have a fixed shape and volume. So that means that they just stay at the same shape and volume. Imagine an ice cube. It's not like changing shapes or changing volumes unless it's melting. Next up is liquid. This temperature is higher than a solid, as you can imagine if you imagine an ice cube versus water. These molecules have a little more kinetic energy than solids. And it has a fixed volume, but a changeable shape. So take a look at my water in my water bottle. The volume is staying the same. That level is never going to rise up and change volume unless I add more to it. But it can change the shape. If I just move it around a little bit, it is changing shape. And last one, gas has the highest temperature, and these molecules have the most kinetic energy. That just means they're moving around the most, they're bumping off of each other, etc. You can both change the shape and the volume of a gas. Okay, that was a lot of notes. We're just going to do a quick review of that, and then you are going to fill out the Google form that is in this classroom assignment. All right, so atoms are individual little building blocks for everything that makes up the world. Molecules are combined atoms. So maybe they're the same atoms, or maybe they're a couple of different atoms together. And these molecules can get way bigger than just 3 atoms also. The 3 states of matter that we're focusing on are solid, liquid, and gas. Remember that solid is the coldest. If you add some thermal energy, you're going to get a liquid eventually. If you add more thermal energy, you're eventually going to get a gas. All right, and then our final estimate here. I don't know if anybody bothered to do the math about how many atoms are in your body. It is about 10 octillion, which is a number that I had to Google, but this is how many zeros 10 octillion has. All right, so that's between all of the cells in your body. This is the best estimate that I could come up with. Okay, that is it for today. Go ahead and fill out the Google form that is attached to this classroom assignment, and please make sure you email me with any questions.